main practicalities of the system, obviously, there's various aspects to which we can actually implement within a data center environment. We can obviously implement such things as peak lopping, where we basically reduce the maximum peak load of the data center on the grid. Now that can be done in various aspects. We could either take power from the batteries, or we could basically take the site off the full grid and then basically apply it onto generation, but that's more of a complete off-grid ready system. So in terms of the peak lopping element, where we basically, in peak times when the grid is unstable, if a data center is told not to exceed X amount of power, then effectively what we can do for those durations is to actually prevent the rectifiers from pulling any energy from the main supply, and hence we're sharing energy between the main supply and the batteries. And by doing that, basically what we can achieve in that way is, if for example we tell a system you can't exceed 1 megawatt, and the load on the UPS system which is being applied onto the grid is 1.2 megawatts, then effectively what we can do then is actually provide 1 megawatt from the grid and take the remaining 200 kilowatts away from the batteries in that way. And that's effectively peak lopping. Now obviously that's only a relatively small amount, but obviously if you multiply that by the number of data centers around the UK, then obviously that's a significant amount of power. Now, in terms of the security that element, I would have thought that would be more accepted by the data center managers, because effectively it's doing one of two things. It's testing their battery systems, because in the event that the battery system is not able to support that, we've got backup methods that we can basically put the power back onto the grid again, or they can back out onto the generation. So there's a lot of protective barriers there. And in terms of peak lopping, if we if we took 200 kilowatts off every data center in the UK, I mean, I don't know the actual total number of data centers around the UK, but that would be a huge amount of power off the grid at peak time. So yeah, I think it's a case of, we've got to look at how deep we go into the actual, in terms of the criticality levels of which we're going to face in terms of the systems. But in security-wise, overall, peak lopping is probably the easy solution and the most secure. The next stage would be to obviously to take a data center off grid as and when the DNO or the energy supplier actually dictates that your data center, they want you to remove it from the grids, which in the event could remove 2, 4, 10 megawatts off the grid in one hit. The problem is with that is then the data center manager not only has to have full faith in the UPS systems, but also has to have full faith in their generators as well. And depending on who you talk to, some data center managers will feel that their generators are more reliable than the grid, as other data center managers feel that the grid is more reliable than their generators. But they've always got the concern of having a UPS system in between, which is obviously has to provide power under all the circumstances. So again, they've got to have full trust in that regardless. So it's going to be about convincing the data center managers to accept that kind of mode of operation. And then alternatively, instead of just going off grid, the third option is obviously to inject power back into the grid as and when required. Now obviously we're going down the realms of a fast response grid stabilization system, whereby in the event that the frequency drops, then we inject power into the grid from the batteries. Or if the frequency increases, then obviously we take power from the grid to inject into the batteries. Now, in order for us to be able to actually perform that task, what we have to have a very advanced and monitored premium battery system. And when I say that, ideally for this kind of solution, the best technology that we could use would be a lithium solution, which I understand that in many aspects the lithium solution is not favoured by some data center managers because of the concerns of lithium and so on, which at the moment is becoming more of the norm in the marketplace, because cars are driving around with lithium batteries in. Lithium batteries are used more and more. Unfortunately, there have been some scenarios where lithium has not obviously come out in a good light with regards to the various foam problems that they've had with batteries going on fire. But the lithium battery systems that work with the UPS are far more advanced than those systems. And basically the lithium battery provides us a greater flexibility in terms of holding the lithium blocks and the batteries at a particular charge rate, whereby we can, say, provide 50% of the battery for grid injection, so we can put half a megawatt's worth of power into the grid for 1 minute, from lithium batteries, but there we always then leave 30% of the batteries available for the on-site load in terms of the data center, and then the remaining 20% can be used there then for taking power from the grid. So in the event that the grid frequency drops, we inject power back into the grid via the UPS by what's referred to as a smart grid ready UPS system. And so we can take power from the batteries, inject half a megawatt into the grid, or in the event that frequency increases, we can then take power from the grid in order to put the energy into the batteries. And then by doing that, basically we still always maintain that the battery system always has more than adequate level in order to support the data center at the same time, so that in the event that there is a power failure, the data center is still secure. We have a battery system which is very closely monitored, so if it's a lead acid system, we have intelligent battery monitoring on the lead acid system. If it's a lithium system, it naturally already has a monitoring system in the lithium battery monitoring system, which can provide us all of the various aspects of monitoring of the battery system to make sure that the battery system is indeed secure. And in reality, in terms of the data center manager, I can guarantee that if you had a system of that type, that the battery system would effectively be far more secure and far more well maintained than a standard battery system on any data center, because it would be actively being monitored permanently, hour by hour, minute by minute. And instead of a battery system failing when it's needed on a data center, this battery system would effectively be in continuous use and be tested, being monitored all the time. So in reality, the likelihood of the battery system failing, which is generally the most common point that a UPS system fails when there is a problem, is a far less chance of that system actually failing. And so really that's a plus for the data center manager in terms of availability, should I say.